more nanotechnology, you know, but since I have kind of changed my mind because I know about the negative effect, environmental impacts of it, so I was just wondering how would that in your world would be sustainable?
No, we're just looking at.
You guys, okay.
No, we're just looking at material costs and that, not pro. You know, we're more of like chemical engineering. This is more chemical process, but nanotechnology in terms of devices and materials, not classical, you know, electron or cell development or things like that. We're just classical materials. That's it.
Just a point of information. This is the original system that was built back in Nigeria by a few of the members of the team. So you have the biodigester here, green, and then generator around it.
Don't get me wrong, I just think that you can cure everything with nanotechnology, you know. I'm like, maybe this is the messiah of technology, you know. But, you know, there's pros and cons of it, so, yeah.
So you're basically just making anaerobic digestion, like you're building a system that's readily available for more people. So you're just making it, like, less expensive.
And then we're scaling it up and down, because, you know, most of them are massive plants, but we scale it up and down. So people, especially in developing nations, this technology is very, very inefficient, and nobody even wants to invest in this thing because people have things like incinerator now. In those countries, you know, corruption is a big problem, so nobody wants to start this thing up. So that's how we, at least enter the market, and our scalability is a big thing. So we can offer ones for small homes, large systems, and then entire communities as such. So we're very scalable in that sense.
Well, even just starting anaerobic digestion here, because I don't think most people even know what that is.
Yeah. Actually, the UCSD microgrid runs on anaerobic digestion. They send out all the sewage from Point Loma, and it powers up the grid here. But you're right, not too many people know about anaerobic digestion. So.
From our research and production of this system, we've managed to be able to, we've estimated the amount of electricity to fuel about maybe like 10 to 15 households, as it takes about 7 to 10 days for that for the biodigester to churn out the waste and produce the methane gas. So we can use that to convert to electricity. So it's not a long process. You know, 7 to 10 days. It's not very bad at all.
And also, when we produce this electricity, we can do it at 5 cents a kilowatt hour, versus here, which is I think about 15 cents, if I'm correct, in the state of California. So we actually have 1/3 of the price. So that helps a lot of people out. And we can produce, like, if I'm correct with my estimates, we do about 14,000 kilowatt hours per year. Or no, 14 million kilowatt hours per year, sorry, with our large scale system. And we get biogas, which is about 2 million gallons of biogas per year. So both ways is a win-win for us.
Is the waste only organic, or can you like implement like paper or like anything like that?
No, it has to be separated and organic. You can't if you that's the biggest, I think, challenge that we have in developing nations is not many people understand recycling, composting. So they just put it together. So the separation part is the hard part, but it has to be a separate process.
Okay.
You can't mix them together, otherwise the reaction won't work.
Will it happen at different times, like because different things have like decomposition rates?
Exactly.
Okay.
So you wouldn't want to separate them, organic, non-organic. Also, waste is of different kinds. Here in the United States, there's more like dry waste. There's more wet waste. So you have to understand the environment, the conditions you work at. So there's a separate process for every nation. So if you implement the same technology here, it will not work there because of simple wet waste and dry waste concepts. So you need to understand what kind of system you build before you enter the market. So that's where that research factor comes into.
So you will have to build one specifically for each country, basically?
Not each country, but like in the subcontinent regions, more regions. Like subcontinent and all have more, wet waste oriented things, but the Northern America region don't use too much wet waste. So that's a separate, so it's a region based. It can't work the same everywhere.
Right.
All right, thank you.
Thank you so much.